Sounds good. And this is a pretty fun talk because I technically learned about DBT just a couple of months back. And I had to demo it to over 100 plus folks when I was at the Snowflake Summit just this month. So it was a fun experience. And I guess I will be showcasing the very same demo. So let's get back into it. Hi, everyone. My name is Harsh. And as Brian already introduced, I will be talking about how you can run dbt workflows locally using LocalStack's Snowflake emulator. So my agenda is pretty straightforward. We'll understand what dbt is for anyone who has not came across this before, and we'll try to dive into some challenges that teams particularly face if they're trying to build dbt workflows, especially against production Snowflake instances. So things like latency, cost, the overall developer experience, and all of these things. After that, I will introduce you to the local stack for Snowflake emulator and actually show you how you can use to develop and test these dbt workflows right on your laptop. And I will be covering up like how you can set up a local dbt environment. You can connect to the Snowflake emulator, run your models without touching a real Snowflake account unless and until you're ready to deploy. All of this with a hands-on demo to just show you how all of this basically works in practice. So without much ado, let's jump directly into the talk. So yeah, let's maybe talk a bit about what DBT is and just give a background for this overall session for anyone who is not familiar with this. So DBT stands for Data Build Tool, and what you can imagine this as, like, it's an open source tool that simplifies your whole data transformation process within a data warehouse platform, something like Snowflake. The key thing to understand is that DBT specifically focuses on the T in the ELT, so basically the transformation part. So what it does is like it takes the raw data, it transforms that into something of a structured model that you can query, and something that your business users can basically start working with. But one thing that we should keep in mind is that DBT isn't just for transformations. You can actually like bring a lot of best practices that you find in the software engineering world. So stuff like modularity, version control, testing, automated testing, and comprehensive documentation. And as you can see in this diagram from DBT Labs, you can basically fit DBT between your raw data and your transform data. And once the data is transformed, once it is ready, you can actually start feeding this into whatever BI tools that you're using right now. Going next, yeah, one thing that we can basically talk about is that the challenges that developers most commonly faced while they're trying to develop and test like their DBT models. So DBT is great, but obviously developing it against production Snowflake instances would also come with some real challenges, something that we have already seen in the AWS ecosystem. The first thing that I would like to say is that there is something that I call as the testing tax. Every time you run dbt during development, you're always going to consume very expensive Snowflake compute credits. Now, if you're doing this once or twice, you won't be able to notice that. But slowly over the time, if you have got multiple developers working on the same project, this adds up very quickly, especially when you're iterating on any complex transformations. Second, developers often don't get any real-time feedback on the cost. So you might write code that seems very convenient for you, but that actually ends up being very expensive to run. And you only find that out when the bill actually arrives. And the third, there is obviously going to be a latency issue. So if you're querying any significantly large data set, you might end up just waiting minutes or even hours for getting your results. That's time. That's a time that you could actually spend on much higher value activities. There are many other issues as well that I have not listed over here, but you can just imagine stuff like data loss, data corruption. That is very common during development and testing phase. The data governance is going to be a very hard thing to tackle because if everyone has got access to production data, that's going to create so many compliance issues during your development phase altogether. So, considering these challenges, you might start wondering what exactly is the answer for that. And I guess like this is something that a lot of other data developers have also noticed out in the community is that what if you could just run dbt locally? Because right now, dbt development typically requires a very good connection to a remote Snowflake instance. And this does not fit well into a local first development lifecycle that most of the software engineers might already have experience with. Uh, So the question really is there any way to run a local data warehouse just for development and testing? And I guess we went through a lot of these community posts on Reddit, on Stack Overflow, on different platforms altogether. And we noticed that this isn't a new problem. It isn't something that we are trying to solve for. It is something that most people are facing nowadays. Many developers are just looking for a way to build and test their DBT models locally to achieve two simple goals. They want to save the money and they want to increase their development speed. So the ideal development experience is very simple. And this is something that we basically had a mind map about, and we basically went on to tackle this. You want to set up your DBT project, you create a local DBT profile, you start a local instance that emulates some sort of a warehouse operations, you run all your DBT commands to validate your changes, and only then push your finished code to production via a CI/CD pipeline. So this is where we introduce LocalStack for Snowflake. If you attended our last meetup, we basically released the LocalStack for Snowflake 1.0 product last month, and we did the GA this month, which basically means that now you can use our product to basically emulate Snowflake directly on your local machine without having to really connect to any real Snowflake instance out there. So this product is shipped as a Docker image. You can typically install it on your laptop or your CI environment. And the key thing is that it is actually emulating the real Snowflake API surface. So you can integrate natively with all the existing Snowflake tooling, and that basically includes DBT as well. So once you have this emulator running on your machine, your JDBC connections work, your data visualization tools work, and everything works out of the box because we are providing the same API that the real Snowflake does. And because it's containerized, it's really easy to extend this particular development model from your local machine to your CI pipeline for all the automated testing and development purposes. So you might be wondering like how complex it would be to set up dbt with LocalStack for Snowflake. And turns out that it's pretty straightforward. All that you need to do is just create or modify your profiles.yaml file that you might have initiated for your dbt project and include all the connection details for the LocalStack emulator. So the key thing that you will need is setting up the LocalStack host, which in this case is going to be snowflake.localhost.localstack.cloud. This is entirely running on your machine because we ship a DNS server alongside our Docker image. And apart from this, you just like need to set some test credentials. So stuff for your username, your password, and optionally, you can also like fill in your database parameters, your warehouse, and all of these particular things. You can just set all of these things to test and it would just work out beautifully. The best part about this is like it's very much like a regular Snowflake profile. So your existing dbt project does not need any particular changes over here. And as I mentioned, you can basically use the same set of commands that you use for running your dbt models. So you can just do a dbt run and you can configure the profile to the one that you created for your local stack emulator. And this will just work out in the same way. The reason for that is because we strive for a one-on-one parity with the real Snowflake API. So you don't need to make any changes to your models or any of your existing code after all. Like your dbt project just works locally, which is pretty great, in fact. Now, with all of this done and having a very basic idea about what LocalStack for Snowflake offers and how you can get started with dbt development locally, we can talk a bit about the demo that we will be looking at. So in this demo, we are basically going to build an end-to-end data pipeline for a smart factory monitoring application. And we will be running the entire thing locally. So the general pitch is like, just imagine you have got a smart factory, you have got a bunch of different machines, and each machine is tracked by different IoT sensors. And it's collecting all sorts of data. You're basically getting stuff like machine IDs, timestamps, temperature, vibration, pressure, status code, and all of these things. So you have got all of this data in CSVs, and they are being stored on the S3 buckets. And you want to have a pipeline that basically ingests all of this data from my S3 bucket, passes it through Snowpipe, and then you can apply your dbt transformations, and everything can be queried via a locally running Streamlit web app. Now, these dbt transformations can be either done manually, like you can individually execute dbt run, or you can actually run an orchestrator like Dagger, whatever basically fits your workflow. The key thing is that everything runs locally, so you can develop and test this entire data pipeline without actually touching any real cloud resources. So let's jump straight into it and see what this demo has got. So I have got everything running on this GitHub code space. And as I particularly mentioned, we have got the CSV file, which is sensor data batch1.csv. And as you can notice, we have got machine IDs, we have got timestamp, temperature, vibration, pressure, and status code. So the first step in this process is going to be starting our local stack for Snowflake emulator. The way that you can do that is using the local stack CLI. And in this case, I'm just going to specify local stack start. And I'm going to specify the stack flag and mention that I want to start the Snowflake emulator. In fact, if you're coming from the AWS emulator, like this command might look very familiar, but under the hood, it is just starting our official Docker image as a container. So you can technically use Docker CLI or Docker Compose or any container orchestration tool to get started with this. I'm using the one that is the simplest that I can use. So as soon as you execute this, this is going to start up my emulator. And as I mentioned before, it is going to expose the emulator on snowflake.localhost.localstack.cloud. And this is what we are going to use to integrate my DBT workflows or whatever integrations that I'm looking to use to get started with the whole thing. So if we just go back to our architecture diagram and let's like looking just at what we want to achieve with this process, is that the first thing that we want to set up is all my actual Snowflake resources. So this would mean my schemas, my databases, my tables, my Snowpipe, and all of these things. So basically have my Snowflake infrastructure already running so that I can start integrating the other pieces to this. So let's go back to my code space and let's actually go ahead and create all my resources over here. So I'm using a makefile target for my particular purpose, but under the hood, it is using a very simple command, which in this case is executing the setup Snowflake SQL script. And if I actually show you the script over here, this is creating my database, my schemas, my tables. I'm setting up a file format for my CSV file. I'm setting up a stage that points to a local S3 bucket. So this is where my CSV file is going to get uploaded. And this will trigger the Snowpipe, which is going to automatically ingest all of this data right in. So let's go ahead and let's execute this. And this is going to use the official Snowflake CLI that has a connection set to my local stack emulator. And this is going to create my database, my schemas, my tables, and all of these things. And once this is done, you can actually notice that my database is now seeded successfully, which means that everything has now been set up. The second step in this process is going to be creating my S3 bucket, which is going to be instrumental because we have got a stage that's pointing to my local S3 right over here. So I can go ahead and I can just say make AWS. And this is a very simple Python script that uses Boto3 to create my local AWS resources over here, which is the S3 bucket in this case. And finally, I can go ahead and say make upload, which is going to upload this sensor data batch1 file to the local S3 bucket that I just created right now. So go ahead, do a make upload, and you can actually see that my file has been uploaded, which means that we can already start running some preliminary queries because we have got some raw data already available in my Snowflake emulator. So I can switch back and I can show you some of the SQL queries that we can run. In this case, I'm using the Snowflake's VS Code extension. So I can just go ahead, click on execute, and you can actually see that it's using the same Snowflake SQL dialect. And I have pointed this to my local stack emulator, like right in this case. And this is like already like doing the job of like running everything against my local emulator and getting me all the data that I particularly need. So you can see that I have uploaded 500 records in my local stack S3 bucket right now, which is now also available in my Snowflake database. I can also execute this and you can get to see the top 10 data available right in this case, which is very instrumental for all sort of development and testing processes. So now that we have this done, we can actually go ahead and like do the next step in this process, which is going to be the DBT transformations. So in this case, what I can do is I can just run make DBT. And this command is technically wrapping up like this very simple command, which is dbt run, setting up the profile to local stack. If I actually show you my profiles.yaml file, you can see that in this case, I have set up a local stack profile over here. The type has been configured to Snowflake. And for rest of the data, I have pretty much set test credentials. The database has been set to factory pipeline demo, which is the database that I'm using for my demo app. And the most interesting part is that the host is set to snowflake.localhost.localstat.cloud with the port being 4566. So that's all you need. You can just technically drop this in right in your DBT project, and you can like, technically run your DBT workflows locally without having to do anything else. So I can just go ahead, do the make DBT command, and this is going to start executing my DBT models. And the very best part about this is like it's pretty instantaneous, it's pretty fast. So you don't have to like do any of the other things to like hyper optimize your development and testing phase. And as you can see, like we had just like an incremental model, a view model, and a table model. It is now completed successfully, which means that our data has now been transformed and it is finally ready to be queried by any particular BI tool. In this case, I'm just using a simple Streamlit app for demo purposes. So I can just like do make Streamlit, and this is going to activate my Streamlit app, which is on this UI.py file. And I can show this to you on the other tab that I have right over here. And hopefully the demo gods are with me, and this should not hopefully break. Yes, it is not breaking. So you can actually see the smart factory health monitor running right over here. You can see that we have got 10 machines. One of them is healthy, two of them is critical. And that's the average risk score that we have got. And all of this is basically getting the data right from whatever data is basically transformed by the DBT project that we have got. Uh, so yeah, that's how easy it is for you to get started with like running your DBT workflows locally. The best part about this is like you can technically integrate DBT with any data orchestration tool that you're using right now. So you can use things like Apache Airflow. LocalStack has already got support for the managed Airflow service provided by AWS. You can also use things like Daxter or Prefect, for example. In this case, I have got a simple setup that can show you how you can run a Daxter pipeline in conjunction with your DBT project. So if I just do a make pipeline, and this is going to activate my Daxter project and my Daxter services, uh, you can actually see that this is running on localhost 3000. And if I switch it back over here, that's where I can see all of my DBT models. I can see the runs, and I can see the other aspects to this. For example, I have got an S3 file sensor that's automatically gonna execute my DBT models once it finds a new file in my S3 bucket. So if I actually show you how I can test that is I can go right here and I can just say that I want to upload another file, but in this case, I want to upload the latest batch file that I have got. And this is gonna upload my file again to my S3 bucket. And if I go back right here and show you this, it's gonna take a few seconds, but you might start noticing that a new run has been invoked. And my Daxter pipeline is gonna take up all the files. It is gonna re-execute the DBT workflow. And once it is done, it is gonna put the whole data back into my like final table, and you can query that directly from your Streamlit app. So let's hope that this is actually invoked. Yes, it is. And you can see all of the data logs right over here. And this is going to take a few seconds because it's going to execute both the DBT models that we have got. And it is also going to execute all of the tests that we have in this case. So I guess that's the best part because not only you can build your data DBT models and validate them locally using the LocalStack emulator, but you can also start like running your tests directly against the Snowflake emulator, and you can get to see if you're basically like passing through all of the data quality testing or all of the other testing that you have particularly got for your project. So we can leave it running. It's going to be successful. Hopefully the demo gods are in this case. But yeah, we can basically switch back to this and we can have like a fully local data development and testing workflow running directly on your machine. In this case, it's a code space, but yeah, it does not matter. You can basically take the same container and you can technically run this anywhere you want. So switching back to the slides, I guess we are very much at the end of this particular talk. But a few of the points that I would like to emphasize for this is that LocalStack is here to basically enable a shift left approach for DVD developers. So you can technically use this particular development model for rapid prototyping, for safe experimentation, and you can get incredibly fast feedback since everything is running locally. The best part about this is like it eliminates all the testing tags, and you can just debug your entire workflow and not just a single model. Uh, so this local development model, so you can use that for all the rigorous testing, and you can run your whole stuff on your local machine before you actually push your code to production. And this is obviously going to lead to a very high quality data development process. Now, if you're a part of a team and you might be wondering, like, how should I exactly get that data in my Snowflake emulator? So right now you have got two ways. You can either manually load your data using a stage, or using a storage integration or something similar, or you can use some of our technologies like CloudPods that basically allows you to take a state snapshot of your local stack instance, and you can distribute that across your entire team so that it can foster a very efficient and collaborative environment for all sort of data development. Maybe one of the future media talks is exactly going to talk about this whole development process. So this brings us to the end of our presentation. So thanks everyone for staying till the end.